Hello and good afternoon. Please, my name is Nortey. Elvis, if you can make me a co-host so I can manage some of the recording as well. If you can hear me, please kindly type your names and index numbers in the chat room for me. Okay, so today we are going to look at introduction to this course. In the first place, kindly take note of some of these details. On your program schedule, this course is called Linear Algebra. Okay, now I've also spoken to your director about it. And the details of the course, you realize that will be fundamental algebra and calculus. So this linear algebra is a name, but the topics that you come across are things you find in fundamental algebra and calculus. And the maths departments on campus, the regular students, this is Maths 111. So I think it's just a name issue, but basically the things you are doing will be the same things the regular students are doing. So take note of that. So if you go online and you see the name Fundamental Algebra and Calculus, please, that is the same that is being referred to here. Okay. Okay, so today we are going to go through some few things. One, things that you need to know to be abreast with this class. Then two, go through the course outline, and then introduce you to an online platform known as Socrative. And then finally, we'll go through the first introduction. Okay, Osman, what's your question, please?
Thank you, sir. Please, I want the host to allow me to record.
Actually, I'm also asking the host to make me a co-host so that I can manage the recording too. But
okay.
I've sent that information. I don't know whether normally it's ICD that co-host, that host, but I don't see ICD here. So I don't know whether Elvis is recording. Elvis, if you can make me a co-host, and those who are asking permission to record, I also need to record too. But so when we give the command, please help us to get that done. Okay, so let's go on. So you'll be looking at steps to follow so that you're abreast with this class, the course outline, and then Socrative, and then introduction to the first lecture on the algebra. These are the things that we will want to go through. So I'm going to share my first screen that has to do with the steps to follow. Now, these documents can be found on the LMS. Now, your LMS, I started populating it just this Friday. So they open it just I think Thursday or Friday. So I'm still populating it with details. But the information I'm using today, hopefully by the end of today, all of them, if not all, will be on the platform so you can access it. So let me share with you the first document, steps to follow to be abreast with this class. Again, this document can be found on the LMS, basically. Okay, so on your screen, you should see that information, steps to take to be abreast with. I'm calling it algebra class, but please take note, it's not just algebra, it's algebra and calculus. Now, the first point here is that you should have registered by now, and you should be on the ICD Directorate, their platform. And then this website that you see here, for the students, this is for the lecturers. For the students, they call it SIP gctu.edu.gh. So please, your website to access this information can be found on the SIP platform, not on the here. It's sip.erp.gct.edu.gh. Right now, if you type this, you can't go here. These are for lectures. This is where your information can be found. So I am briefly going to go to that website to show you what I'm referring to. So now, maybe let me just type it so that you see that that's what I'm referring to. But I'm saying for you students, it will be SIP platform. So this is the erp.gct.edu.gh. Sorry, not this one. Okay, so that is the website. I have already logged in, so it is saying my page. Now, if you come to my page and then you go to my courses, all the students that have been populated to my course can be found here. So these are the students that I have. I have a fundamental logic and sets. I have a fundamental logic and sets for some groups, computational stats, actuarial science, and BIS. Okay, so let's look for you, distant learning. Now, so you can see that I don't have distant learners here. I hope I'm at the right place. I don't have my distance learner. Let me check whether when I go to pending, I will see you. Okay, the distant learners I have here are my algebra class. I had that class yesterday. That is for BIT, Information Technology. Okay, so it means that your class has not been populated to my page yet. Okay, so when that is done, I'll see you. But let's see what happens when your details are in my page and then at the end of the semester, results are populated. So I'm just going to pick one class, one simple class. Let me pick a class which I can deal with. Okay, Baba, what's your question, please?
Sir, good afternoon.
Good afternoon.
Please, I wanted to know if this class is for electrical and engineering students or IT distance learning.
Please, this class for electrical engineering. Are you okay? Okay, so I am saying that when your details are populated onto the ERP, then when results are populated at the end of the semester, you will see your details shown on your SIP page. Now, I am on my page, and being the lecturer, I teach IT, I teach engineering, I teach computer science. So the things you are seeing on my screen are my students, okay? So I'm just showing you students that I have taught in the past and their results when it is shown how they look like. There's a reason why I'm showing you this, so that subsequently during the semester, you can be able to handle information that you get. Okay, so I'm picking, for example, an example of a class that I've handled. So this is BIT class last year, algebra. Now, kindly take note of the following. So what you are seeing here are their results. Okay, now look on the right. The results is made up of their class score, made up of their exam score, and then made up of their total score, and then finally their grades. Now, what I want you to look at is the alphabet that represent the grades. Okay, look at the alphabet. Now, do you see this? There's an alphabet called IC. Okay, there's an alphabet called IC. And then sometimes you see there's an alphabet called X. Now, I will come back to these values later on, but take note of it. So basically, at the end of the semester, if you have done what you are supposed to do, when we upload your results, this is where the results are uploaded and you will be placed on this website. Okay, so take note of it. Right now, you haven't written anything. So if you go to that website, you will not see any results, but this is one of the websites. Now, the second website is called the Learning Management System. Now, this Learning Management System happens to be the place where we populate all your lecture materials. Now, being a distant learner, we interact solely online. And we have just few classes that physically we meet. Now, I'm going to go to my LMS and show you your course and your details. Again, like I said, I am working on your class, so your details is still being populated. I'm talking about the materials that you will use for this course. Okay, so let me just log in. Okay, so if you're a student, to log in, you will be given your student's email address and a default password. And then you log in and then you see these details. Okay, so I'm logged in now. I'm going to my courses and then identify your course. So this is linear algebra, distant learning. So this is your course, first semester. Now, at the beginning of the course, you see that I have detailed of the course. The summary of what this course is, like my name, my WhatsApp number, my email. And then you have the course announcement. Then you have the course outline, which I'll go through after this. And then you have the model textbook for this course. This model textbook is being uploaded here. The link we are using to meet today is here. And then you have Socrative, welcome. Now, then today's first lecture, which will be made up of Introduction to Functions, Trigonometry, Exponential, Limit, and Continuity. I have it as a PowerPoint, but I'm yet to upload it because yesterday evening I was adding a few things. So I'll use the PowerPoint when we finish the class. I'll upload it here. Now, this is a document I'm going through right now, steps to be abreast with the class. Okay, so when I'm done, you will see the PowerPoint also underneath here. And if there are exercises that I'll give you, I'm going to populate it here. So this is your page in which you are supposed to be to access information. Now, when I go to participants, for example, I don't know whether Elvis is a student here, but if I type Elvis Atta, if he's a student in this class, then I should see Elvis here. Now, I don't see Elvis here. Who else is also here? Abdullah Sani. Abdullah Sani. Second time. Who else is here? Who can volunteer his name? Edward Boyson. Let's see Edward. Edward Boyson. Yes, please. I don't know. The network is that bad. But basically, is there anybody here that has been able to log into this page? I don't see Edward here.
Tete Emmanuel.
What Emmanuel?
Tete Emmanuel.
Emmanuel Pepe. So Emmanuel P. Okay, I don't see you here. So it means that Center for Online code are yet to populate your details into my page. Okay, so please, if you go into the Moodle platform and you can see other courses, but you don't see linear algebra, then it means that your details haven't been populated. Please, that job belongs to the Center for Online, and they are supposed to populate you. I told you that they created this just, I think, on Friday. So I even started populating it for me. It was just yesterday I started populating this page. So I am sure they will do the rest to make sure that you can access this. Okay, so these are the pages which we will be interacting with. And just for curiosity's sake, the BIT class, that is distance learning, which have been there, I've taught this course for about a year. If you go to that page, for example, you see that it is similar to your page, okay? And then the lecture material, because this course has run for 1 year, their lecture materials, their courses, their quizzes, they are all here. So this is how the model page will look like by the time we are done. So every week, whatever we are going to do, you'll see it there. If there's assignment, I'm going to populate it there, and then you can access it. Okay, so basically, this is how the LMS work. Your platform that you interact with your lecturers. This is where you find every information concerning that. So that is the learning management system, lms.gccu.edu.gh. Okay, now the third information that you need to know is, what is this course all about? So that will be found in the course outline. I've showed you that the course outline is on the page already. But let's go through it briefly. Like I told you, please, the institute calls this course linear algebra. But we at the maths department, we call it fundamental algebra and calculus. So there's more to it just other than linear algebra. At the end, your results will show linear algebra, but we are going to give you all the details you need. Now, the first page has my details. Okay, everything about me is here. The second page talks about all the topics that will be found in this algebra course. Okay, so you can take your time and read it. Things like complex numbers, function, vector algebra, matrices, polynomial, elementary functions, applications of limits, and virtually will end on application of integrals respect to calculus. So these are the details of the course. Now, at the end of the course, things that you should be capable of doing: 1, to simplify or manipulate complex numbers, to geometrically be able to represent complex numbers in Argand diagram and in polar form. How do you represent vectors in vector spaces? How do you compute things like dot product, scalar product, and vector products? How do you solve systems of linear equations? How do you determine the limit of a function? How do you compute the derivative or antiderivative of a function? So these are the outcomes. Okay, so when we are done, questions that you will come across will be testing you on your ability to simplify, to represent, to compute, to solve. The verbs you see in this particular paragraph is what you'll be determined by virtue of the questions you see. Now, there are so many books that are recommended for this course. For example, there's a book on calculus, early transcendent, and this is on Cengage. There's also a book on advanced engineering maths, and then linear algebra. All these books, some of them can be gotten online. Others, you can get them from the electronic library that your students are supposed to be able to access. I'm told that GCCU has an e-library that students can access. Okay, but for for distant learners, okay, when I went to your page, I showed you that everything about the course, there's a model book, this book that you have here. This book, model textbook for linear algebra, is already available on the page. So for example, whatever I'm going to do today, you see that it will be in session 1, session 2, session 3. I've already opened that document, so I can basically step through to show you that that is exactly what I'm using. So let me just show you a copy. You can download it. It's virtually for you, so you can virtually download it and use it as a resource. The textbook are supposed to be materials that we use to support what we are doing. So this is the textbook. This book was written by one of the department lecturers. It's called it's a Franco Poku, and let me say Ike Mensa. But I am teaching the course. So you see that today we'll be looking at introduction to function, polynomials, trigonometry, on and on and on. So the arrangement of the topics and the courses have been designed in the book. So when you go to chapter 1, introduction to functions, then you have a session, then you have a definition, then you have examples, and then you have a little quiz at the end. That's how the book has been designed. Okay, so this book is online, it's on the platform. You can access it. When you finish, you'll be given some self-assessment questions that you can try. Okay, so that is the model book that can be found on the platform. And I'm saying is available there. So these textbooks are just supporting materials that you can also use if you need more resources. Now, at the end of the course, how do we assess? Now, this is the first time which this program has been mounted online. But normally, for me, I take individual assessments, which are done online on the platform, and I take group assessments, and then I take quizzes that you'll be found on Moodle and Socrative. Now, again, like I said, because it's the first time we are mounting this course, we are designing your assessment alongside this. But what I can tell you is that for me, all my assessments are online. The only exams you come and write may be the final exams. So if there's a midterm, it will be online. If there's a quiz, it will be online. Everything which you'll be assessed on will be sent to you via the Moodle platform. And sometimes if I feel that the work is voluminous, I don't know the number of students you have in your class. But right now I can see 24 students logging. I don't know whether you are up to 100 or less than that. But most of the times, my classes that are large, their assignments are group assignments. So they divide themselves into groups and they submit one solution. Now, as we go on, looking at your numbers, we'll decide. But there will be group assignments which you will have to submit as a group. And I'll show you how to form your groups to do that. Okay, now, so assessment can be graded using these percentages. So the mid-semester exams will take about 30% of my assessment. Your group assignment will take about 5%. Your class attendance virtually will also take about 5%. Your exam will take 60%. So my total mark for a student that is in my class will be graded like this. And these are the grades that I refer to. Now, those who were in the class from the beginning, when I went to the ERP, I showed you a grade of X. Please, X means that you were absent in class. And then IC means that you wrote maybe the mid-semester, you didn't write the exams. AD, if you get a grade like AD means that you are under audit. Audits can be maybe school fees or could be disciplinary issues. Okay, so please, these grades you see here, from here all the way up to this, they are not given to you by the lecturer. They are actually assigned to you by the system, the ERP system. After we upload your results, if, for example, you didn't turn up for something, the system automatically will look at what we have provided and will assign these grades to you. So if in case, let's say you wrote the exams and at the end of the semester, you saw that your grade was X and then your grade was IC, it would be good you draw the attention of the directors of the institute, then they contact the lecturer, and then we update it as soon as possible. You are not supposed to get X, Z, IC, and AD if you did everything that you're supposed to do. But when you get these things, it means that along the time we were having a lecture, something happened, you didn't do something. You didn't write midsem, or you failed to write exams. Okay, so this is what the grades stand for. The last thing on the course outline has to do with the topics, the way they have been arranged. So today, like I said, we'll be looking at functions, and then hopefully, if we can do all fine. If we can't finish, or we'll continue next week. And then subsequent weeks, we'll look at differentiation, integration, complex numbers, matrices, and then finally vector algebra. So this is the course outline. This is what you find in the course outline. Any questions for me? Okay. First lectures are always a lot of introduction. So if you have any question, please let me know. Now, the third thing that you need to be familiar with is how to use an online platform known as Socrative.com. This one, everybody, all the 26 of you right now, you must partake in this exercise. But subsequently, I will not have the time slotted for you to be doing this. So kindly go through this. Okay, I have a hand up. Engineer Philip Ayit. Is it Ayita? Philip, what's your question, please?
Sir, please, the quiz you put on the platform on the LMS, we have done it. I'm trying to submit it, but it is not going through.
What quiz is that? Have I given a quiz? What is the name of the quiz?
Yes, sir. You put some.
Sir, please,
some
is
quiz
the
on it.
E. Answer the 12 short questions.
Hey, when did you go there? How did I? Some of you have been there. Wow, that is what we are about to do. Okay, if you've done it, fine. Others haven't done it. Or it doesn't mean all of you have done it.
No, sir. Sir, the submitting
Okay.
was the problem.
Okay, so I'm going to walk you through it. That's why I'm doing the number 3 right now. So let me walk you through it. Okay, so please, this is how you go about it. You type into any search engine, Socrative.com. So I'm going to just go into one search engine. So I'm opening just a browser and type in here, student login. So I'm typing in here, student login, Socrative.com. So this can be done in any browser at all. Sometimes those who are using Safari, it gives you a problem. So please remember that from what I am showing here, when you are able to log into Socrative, you click on student login, and then you enter this room name. So that's what we are about to do. So we are here. The room name is Welcome, BEEE, Jan 2026. One word, Welcome, BEE, Jan 2026. Immediately you click on join. I hope I have copied well. Okay, click on join. If you copied or you type in the correct room name, it will ask you to enter your full name. Please enter your registered name. Now, subsequently, if I should give you any other exercise apart from this, then you enter your index number. Then you see some 12 questions. So what those gentlemen were saying was that they have finished and they are looking at how to submit it. So if you are following us right now, please kindly go through this all over again. Okay, so I see Samson Asari here. Okay, I've seen myself here. Those who have done it, those who haven't done it, please log in right now and let's see your details here. And if you have done it already and you want to retry it, please go through the process I went through. So I'm seeing Bernard Atta, I'm seeing Samson Asari, I'm seeing myself. And okay, I'm seeing Tete Emmanuel, Bernard Atta, and then Philip. I'm seeing all of you.
I say, is it because you have not, I mean, open your portal? Because
Abdullah, is there a question you're asking me?
Please, I want the room name. I want the room name.
Okay, the room name is this. Here's the room name. It's Welcome. I'm going to put it in the chat room. So it's in the chat room. You can pick it from the chat room.
Hello, sir. But I've
Yes,
previously
please.
done it. I don't know why my name is not
Yeah,
showing.
please, if you've done it, I have downloaded the results. I've sent the results. When I came, I realized that some have gone online and they've done it already. And I knew I would have to revisit it because it's something everybody should be able to do. So if you've done it, it means it is in my inbox. So I won't see your details here. Okay. Unless I go to my inbox and download the results. I don't know whether I can do it right now. If I'm able to, I'll show you.
Sir, please, can we get a room name?
The room name is in the chat room. Go to the chat room. It's Welcome BE Jan 2026. Okay, so I'll be able to open your results for those who did it earlier. So if you want to verify that I have your details, this is the Excel. I don't know what I can see. So I see index number like this, Avoga, Kingsley, then I have Alexander, Sejifa, Benarata, Doji, Kwame, Philip, Aita, okay, Philip, so we done it already. Raymond, Samson Asari, and Samuel Farid. So these were the people who did it earlier. Okay, so this is my inbox. I just opened my inbox. These are the results. So this is what happens when you're able to do Secretive. It sends the results to my inbox and I can download it and then access it. Okay, so if you are yet to do, then just continue and do this and I'll get your details here. Any other question on this?
Sir, please, what is the meaning of the number 1, number 2, number 3 up to 8 also?
You mean this?
Yes, sir.
And these are the questions. You know, when you go to Socrative, sometimes Socrative will shuffle the questions. So what you answer as number 1 will be somebody's number 2. So that will be somebody's number 3. So these are the questions I've asked. So this number 2,
Okay.
please state your highest qualification and on and on and on. When I click
Okay.
on the results page, it will just show like this. And then the answers you are giving me are displaying in the screen like this. Okay.
Okay.
Okay, so I think we've done enough. I have just these few information, then we are done with this. So every time you come online, you'll be given a Socrative room name for a topic we have gone through, and then you can answer questions. Now, look at Socrative. You see that if I go to my library, you'll see all the possible questions that I have in my library. Okay, I have graph theory, relations and functions. You have Hasse diagram, propositional logic, predicate quantifier, rational functions, and stuff like that. So if for example, today I deal with functions, then I will come and ask. So depending on where we get to, then I give you a room name for that question, and then you practice it and give me your results. Okay, so this is how Socrates works. Now, what you are giving me is basically data that I'm collating. So this one, it won't give you a mark. But the other questions, when you are done, it will automatically assign a mark to what you've done. Okay, so this is what you find under Socrative. And the last thing is the group questions, okay? So the group questions should be done like this. Now, if you are 30 in the class, for example, or 40 in the class, you can divide yourself into 8, or you can divide yourself into 5. So you get 8 groups. Now, I don't have any questions on group right now. Please, like I said, I started populating your details just last week. So I don't have any questions to show you, but I will show you an example of a group assignment that I give to my classes so that you see how to submit a group assignment. So for example, this is group assignment for algebra. And then the questions are being arranged in groups. So this is group 1. Group 1 is supposed to solve these questions and then go to the LMS. The LMS, go to your page, wherever the question is showing, and upload your results there. And then group 2 will take another set of questions and do the same thing. So when I went through the course online, I told you that my assessments are from individual quizzes and group assignments. So if I give you a group assignment, then the members in your group, after you've solved it, you convert it to a PDF, and then you can use it to be able to and submit it on the LMS. And when you're submitting it, you add all the members in the group. So that is why I have typed here group name, group leader, and then you list the members of your group. Underneath it, your solution. Okay, you can either type your work if you have access to, or if you are writing with your hand, write it nicely. When you finish, you convert it to a PDF, and then off you go. Okay, so this is what this course is about, and I need you to be familiar with all this information so that when we start, you know what to do. Okay, so we are going to take our first PowerPoint. Please, this PowerPoint, I will populate this PowerPoint on the page when I'm done today. But right now, it is not there. So this is the first time you'll be seeing this. Again, I have to be working on this as of yesterday evening. So when I'm done, I'll put it on the page for you to access it. And then the questions that will follow these topics, I will try and do maybe the first 2 up to maybe a logarithm, hopefully. And then I'll give you questions on them, and then you try it. Hopefully next week when we come, you will have something to tell me whether we need to go over something or we can just follow through with what we've done. Okay, so there's a PowerPoint that we are going to go through. So in the next 15 to 20 minutes, we are going to briefly go through the first lecture or the first unit under linear algebra or fundamental algebra and calculus, depending on which material you are using. Please, like you do, if there's something that you are not clear with, kindly draw my attention to it. And then we will see how best we can resolve what your issues are. Okay, so this is all that you find in this slide. Kingsley, your hand is up, please.
Hello, sir. Please, with the
Yes, please.
with the group studies, you said the maximum should be 8. But with
It's actually okay. It's actually the suggestion. But go ahead. What's your issue?
for the list we are having now is 14 for the electrical and electronics. So with the division, we don't know how we should go about it.
Okay, so if you have 14, is it a combined class, electrical and electronics? If you
I'm
have
sure
14,
some people have joined us.
because I'm seeing 27 here. It may be they haven't. So I use roughly in my head number like 30. So if you use 5, that means that you get 6 groups. If you use 10, you get just 3 groups. It all depends on what will work for you. And because you are not situated at one place, dividing is one. And last year, I left it for the class reps to do, but they found a way. Maybe those who are around the central part of the country, those are the northern part. So I remember those were in the eastern part, like were having their discussion at one. That's how they group themselves. But at the end, they will end up submitting their work. And when we meet physically, you are supposed to meet you physically, I think twice or so, if the calendar is correct. And sometimes when we meet, it becomes going over some of these assignments so that they are abreast with it. But normally for me, when we meet physically, I just do tutorials. I don't do anything new. Okay, so that the things that people did not get during the online sessions, we trash it out. So the groupings, maybe let's use 1 week to see what works for you. So maybe at the end of the class, find out whether there are new members, or maybe ask the directory to send you the list of all the members in the class. And then with that, you can be able to do some divisions. Please, when you are sending your details, tell them where you are. The part of the country where you are, so that sometimes it helps. Or what last year people did was all the military people and the police were in one group, because they know when they are when they are not available, they all can relate. Yeah, just find out what works for you. Okay. I'm not going to be too hard on you on these things. It is a format of learning. So let's see what works for you. And then we can help each other.
Okay, sir. Thank you, sir.
You're welcome. Okay, so in this first slide, because it's a PowerPoint, I have tried to put a lot more information in here. But when it is time to practice, you may have to take your time and be writing alongside and solving some of the problems. But this is PowerPoint, so it's supposed to be highlighting the things that we have. So we're looking at functions, we're looking at polynomial functions, looking at trig functions, logarithm, and then limits of a function. Okay, so I'm sure I can go through maybe the first 3 or the first 4. Going through all of this will be quite a lot, but I have some tutorial questions that at the end I will drop in the chat room. And later on, if you are interested in it, I'll place it on the Moodle platform too, so that you can practice with it. Okay, so let's begin. What is a function? Basically, when we say we are defining a function, what do we mean by a function? Now, normally, if you've done discrete mathematics before, you realize that functions come from something we call relationships. So, for example, if you are in a family, you'll be related to your father, or be related to your mother, or be related to a sibling. Now, these types of relations do not necessarily form a function. So X is a brother of Y, or X is a father to Y. So there's a relationship. You can have X mapping to Y based on the relationship. But before a relationship becomes a function, then the definition you see here, it says that a function will take an element from a set and map it to a unique element in another set. Now, what unique means that if I pick an element from a set A, I can be able to have an image in set B. Basically, that's what it's saying. So you see that if I take, for example, y is equal to 2 plus x plus 2, immediately I take x is 1, y will be equal to 3. When I take x is equal to 2, y will be equal to 4. So element in set A is mapped to a unique element in set B. Then it becomes a function. But you sometimes will see functions, relationships like element in set A is mapped to more than one element in set B. So where the things like one to many or many to one. Let's say one person, he has more than one image in set B. Now, excuse me, this is just being, I want this to be as realistic as possible. So please don't get offended. If you take, for example, polygamy, those who marry more than one. You see that? So the husband can be mapped to wife 1. The same husband can be mapped to wife 2. So you see that X can be mapped to Y1. That same X can be mapped to Y2. That is a relationship, but that is not a function because X doesn't have a unique image. How do you understand? Doesn't have a unique image. So this is a difference. So ability to be able to write a relationship as a function, you must make sure this property is really satisfied. I'll give you exercises that will help you to manage these things. There are some equations we write or relationship we write. They are relations, but they are not functions. All functions are relations, but not all relationships are functions. Okay, the second definition says that when you pick a function, it's a rule that you assign the elements of Y. So the images that you find in Y should be mapped to what we call an element in X. So unique elements in Y should have an element in X. Then it means that a function has been defined. Okay, sometimes when the definitions are a lot, an example helps. So let's look at this map. Okay, so here we have your domain to be R. What is R? And then your function is F, and then Z. So what is R? R is a real number set. What is a real number set? Real numbers can take whole numbers, can take fractions, can take decimals. So if you see that the point in here is 4.3. Now, so when I substitute 4.3 into the function, I'm getting an answer to be equal to 4. So they are telling me that my X value is coming from a domain called R. My Y value is coming from a domain called Z. Okay, one of the values in R is not a whole number, but it is actually the pre-image of the image in Z. Okay, so they are not telling us what equation they use, and 4.3 gave you 4, but they are trying to explain that for this to be a function, when I pick an element in the X domain, it should give me an answer in the Y domain. This is a very simple explanation to what we just seen. Okay, another example. Now, if you take the elements in the left, these are Alice, Bob, Chris, Dave, and Emma. All of them happens to have grades in the codomain, and they are telling us that this is a class grade function. On the right, we are picking alphabets A, B, B, C, C, D, D, E. And all these are mapped to the images in 1. So this is a string of length of functions. Okay, so these are all types of functions that we want to show pictorially. Okay, now let's pick an equation and also interrogate that. Let f of x be equal to 2x, and let f of x be equal to x squared. Now, in functions, properties of functions are, we can add them, we can multiply them, okay? So in adding them, if they have like terms, when you add, you group the like terms. So 2x plus x squared will give you f1 plus f2. And f1 times f2 will end up giving you 2x raised to the power 3. So we can add functions, we can multiply them. Okay, then a function is 1-to-1. Now we are looking at the properties. So what will this help us? When you are given a function, there are 4 things that the functions must satisfy, or there are 4 properties that these functions may satisfy. What we call injective, surjective, bijective, and then we find inverse. What is injective? Injective means that the function is 1-to-1. One person is married to one wife. That is 1-to-1. Okay. So when you pick, for example, those 2 equations, there's one, f1 and f2, you see that f1 equals to 2x is 1-to-1, but f2 equals to x squared is not 1-to-1. Why? We'll see very soon. So 1-to-1 means that when I pick an element in set A, it should map to an element in set B, and that set B, nobody should be mapped to that element. That is 1-to-1. Okay, so here A is mapped to 1, E is mapped to 4, I is mapped to 5, and O is mapped to 2. All of them have what I call one image, and nobody picks that image. But when you come to the right-hand side, look at it. You see that both E and O happen to have the same image of 2. So this function is not one-to-one. It's a function, all right, but it's not one-to-one. Because 2 elements in set A can be mapped to 1 element in set B. Okay, so this is why this function is not one-to-one. Now let's go on. We want to identify the properties, and we take examples. Let's go to, again, this is another example. A function is not injective, it's not one-to-one if it happens to have more than one element mapped to the other. So in one-to-one function, please look at this example. There can be elements in the codomain or the Y that nothing is mapped to it. It's still one-to-one. There's a reason why we are paying attention to this, because the next property is onto or surjective. So as for a one-to-one or injective, is one element mapped to one element in the codomain. But in surjective, you see that every element in the codomain must have something mapped to it. So these are the differences between these two properties. I hope everybody understands one-to-one. One element to one element, one element to one element in a function. Now, so a function is onto. Now we are looking at onto function or surjective. What does it say? It says that a function is onto if each element in the codomain has an image. So this time you concentrate on the Y or the codomain. So look at the codomain. Make sure that all of them, there's an arrow map to it. Even 2 or 3 people are mapped to it, we don't care. We can have many to one. But we must make sure that all the elements in the codomain have something mapped to it. So this is an onto function. But when you come to the second example, you see that the element 3 and 4, there is nothing mapped to it. So this function is not onto. And when you take your time and look at it, this function is also not one-to-one. On the left, the function is onto, but it is not one-to-one. Okay? So these are the differences. Any questions so far? This is quite busy, but I want to be sure I'm not losing anyone. My numbers have dropped to 23. Is it network for people?
Yeah.
Sir, please,
Okay.
I think it's the people.
Okay then.
We were to be lesser than this, but they joined and later realized they were not supposed
They are in
to
the
be there.
wrong class. It happened to me yesterday. So sorry about that. Okay. Or we'll find our level as we go on. Dorcas, you are welcome. Hey, Dorcas, what is by your name? Dorcas AMTP. What does it mean? Interesting. Okay, let's go on. Now, surjective is a synonymous with onto function. So when a function is surjective, we say it is onto. And they are also saying that note that there can be multiple used elements in the codomain. Yes. So you can have more than one element, 1 or 2 elements mapped to the same element in the codomain. That is accepted in what we call an onto function. Now, then we want us to find out. Now, tell me. So these are questions. You tell me, are the following functions onto one-to-one or both? So look at this. A is mapped to 3, B is mapped to 4, and C is mapped to 1. Is it one-to-one?
Yes, sir.
Yes, it's one-to-one. What about, is it onto? Onto, you must look at the codomain. Has everything been mapped to it? So is it an onto function?
No.
No. Okay, so this function is one-to-one,
No.
but it's not onto. That means that it is not bijective. Bijective means that it's both one-to-one and onto. Okay, so that is the answer. It is one-to-one, but not onto. What about this? The second one at the bottom. A is mapped to 2, B is mapped to 1, C is mapped to 3, and D is mapped to 2. Is it one-to-one?
So no, it's
No,
on.
but it's onto. Yes, it's onto, but not one-to-one. What about this? A to 4, B to 1, C to 3, and D to 2. Is it one-to-one?
It's one-to-one.
Yes, it's one-to-one.
Yes,
Is it
one-to-one.
onto?
Yes, it's onto.
It's also onto. So it means that this function is bijective. It's both one-to-one and onto. Okay, another one. A to 2, B to 1, C to 2, and D to 3. Is it one-to-one?
No, sir.
So
No,
no, it's
sir.
not one
Okay.
to one.
And is it onto?
Yeah, 1-to-1.
Yes,
No,
sir.
sir.
On
Yes, sir. It's on to.
Are you sure it's onto? Look at 4.
No, it's
It's not.
not
It's
on.
not.
It's
It's
4
not
is
on to.
alone.
It's
It's
4 is
not.
alone.
Yes.
Nothing is mapped to it, so it's not onto. So this function is neither 1-to-1 because A is mapped to 2 and C is mapped to 2. It's not 1-to-1. It's also not onto because the number 4 has nothing mapped to it. So it's neither of them. Okay, it's neither of them. Okay, now let's come to the fifth one. A is mapped to 2, B is mapped to 1, C is mapped to 3, and A is mapped to 4. 1-to-1. Is it 1-to-1?
Yes, sir.
No, sir.
Are you
No,
sure?
sir. It's not 1-to-1.
It's not 1-to-1. A is mapped to 2
A
images.
is mapped to 2 and 4.
one
Yes.
to many.
A is mapped to 2 and 4. Actually, this thing is not even a function. I'm
One
very
to
sure. It's a function. A function must have a unique image. A function must have a unit. Now A has 2 images. It means that the images are not. So this is not a function. Yes, it's not a function. Okay. So these are examples to be able to help us to find out whether these are true. I don't know. Now there is another one here. I hope I haven't repeated my file. What about this? Is this on 2? 1, 2, 3, 4. My numbers have shifted. I hope you can see, please. The number should come down. I don't know what I mean by, I don't know whether you can see this. Let me take it off. This numbers should come down like this. And this 1, 2 should come like this. And even that.
Then it means it is 1-to-1.
Yes, it's 1-to-1. I think it's my, I can't even, I have to narrow this thing to.
So we understand. We understand that.
Okay, I hear you. Okay, that's okay. So we are saying that this is 1-to-1 and it's also onto, isn't it? It's 1-to-1, both 1-to-1 and onto. Okay, such a function is called a bijection. So this is a bijective function when it satisfies the first one and the second. Okay, so now we are using an equation to be able to prove that these functions are either 1-to-1 and all that. Now, from here, this statement we are making, anytime you're able to show that a function is a bijection or a bijective, then that function has an inverse, and the inverse exists. Okay, so please take note. The only way an inverse of a function exists is when it is both 1-to-1 and it is onto. Okay, so we are talking about inverse function here. So you can start from left to right and come back from right to left. And then you're able to show that the function's inverse exists. Okay, can we define the inverse of the following function? Obviously, if A maps to 3, it means that 3 is mapped to A. If B maps to 4, it means that 4 is mapped to B. If C is mapped to 1, it means that 1 is mapped to C. So the inverse of 2 will not be a function. It's not onto. Okay, so what they want us to do is when you look at the reverse, is it 1-to-1 or is it not onto? So if you look at the reverse inverse function, you see that the number 2 will not have anything mapped to going backwards because the inverse of 2 is not onto. Okay. Now, what about this? What is the inverse of 2? The inverse of 2 will happen to have 2 is mapped to A, and that same 2 is mapped to D. So you see that it is not 1-to-1. Okay, so we are looking at the properties of the reverse function and identify whether they are 1-to-1 or they are onto. So an inverse function can only be done when the function is said to be a bijection. Okay, now the properties. When you pick any function and you are able to show that f naught of g, you can find f naught of g or g naught of f. What does it mean? F naught of g means that g followed by f. I hope you are familiar with this terminology. F naught of g means that g followed by f. It means that you must evaluate g of x first before you evaluate f into bracket g of x. So they gave us f of x as 2x plus 3 and g of x as 3x plus 2. So if we are saying that f naught of g means that we evaluate g of x first, let's find g of x of 1. So let's substitute 1 into g of x. Now 3 times 1 plus 2, when I've given you, I hope you can see, if we place, we are saying that if you replace here with 1, then this becomes 3 times 1, okay? 3 times 1, okay? Plus 2, that gives us the value of 5 here. Okay, so g of 1 gives you 5. Now then we pick that 5 because we are now evaluated the g of x of 1 is 5. Now pick that 5 and put it back as f of x. So we must place 5 here. If you place 5 into this function, 2 times 5 is 10. 10 plus 3 will give you 13. So you see that f into bracket g of x, which is f naught of g, will give you 13. Okay. I hope you know how to evaluate these things. Basically, that is what all this is all about when you are finding what we call composite function. Now, so this can be done algebraically or it can be done diagrammatically. So what I have done, I substitute into the function like this. And that is what they did and to show that this will give you this. Now, let's go on. There is a property we need to look at. Now, anytime you are giving a function and they ask you to prove that f naught of g is not equal to g naught of f. So f naught of g would mean that you evaluate g of x first before you evaluate f of g of x. And then g naught of f will mean that evaluate rather f of x first before you substitute that f of x into g. Now we've taken an example, the same example, 2x plus 3, 3x plus 2. If you substitute g of x inside f of x, you get 6x plus 7. But if you substitute this 2 of x rather into f of x first, before you come and now place that into g of x, you get 6x plus 11. And therefore, we are able to show that f naught of g is not equal to g naught of f. It means that this function, composite functions, are not commutative. How do you remember this property? They are not the same. When you evaluate f followed by g, it's not the same as evaluate g followed by f. Take note of this. It's never the same. If it's ever becomes the same, that means that the functions themselves might be the same as be similar. Okay, I think that will be the end of functions. Okay, so now if you get a question on functions, you should be able to evaluate them. You should be able to either find whether it is one-to-one or it is onto and on and on and on. So we are going to share, or I'll share questions on functions like right from, is this a function? Or if it's a function, is it one-to-one? Is it onto? If it's one-to-one and onto, can you prove that it's bijection? If it's bijection, can you find an inverse? And if you can find an inverse, can you find a composite function? I hope you can remember all these properties. Basically, this is it. I think I won't go too far. I'll do that of polynomials and then we see whether we can solve some questions. Any questions so far? Sometimes I forget that I'm teaching students. So if I am too fast, let me know, okay?
So yeah, it's a bit fast for me.
Okay, so sorry about that. I knew sometimes I go ahead of myself. So just draw my attention if I am a bit too fast. So basically, I'm saying that when you're given a problem, you should be able to handle some of these things. Now, I promised you that I will give you questions that we can practice. Now, for example, this particular tutorial questions will be dropped in your inbox. It will be at the end of the topic. So what do we want to identify here? If you are given these functions or these equations, okay? So tell whether these relationships are functions and where they are possible, give the domain and the range. Even though I haven't defined what range is, range are the results of y. So for example, if I have -5 mapped to -2, -9 mapped to -8, 5 mapped to -7, you look at the mapping and tell whether this is a function or it's not a function. Remember, a function must be, every element must be mapped to a unique image, okay? Every element in the domain must be mapped to a unique image in the codomain. That makes it a function. Then if it's a function, then determine the domain and the codomain. So this will be some questions I will drop in your inbox. So I think they are about 15 sorry, there are about 20 what? Hey, there's a lot up to here. It goes all the way up to number 10. Then there is another one, which also I will want you to try. So this time, you'll be given an equation, and then you are supposed to go through the same procedure, find out if it is a function, what is the domain and the codomain, all this. Now, some of these functions happens to be what we call rational functions. So I may have to introduce you to that. They are functions that are written as a numerator and a denominator. So these are the questions which virtually I'm going to drop in your inbox. So hopefully by next week, when you come back, I hope you would have tried, if not all of this, at least some of this. Okay, so let's continue. This is where we are aiming, or what we are aiming to do. So, okay, so I'm back here. I don't know whether I'm showing the screen or not. So this is a polynomial. Now, what is a polynomial? A polynomial is simply a function that is expressed as a sum of, some books will say monomials, or some will say as a sum of variable and the coefficients and powers and stuff like that. So when you are given any function and then they are being added, okay, and a function is being added to another with some of them with degree or with powers, then it is called a polynomial. So an example is this. AN here stands for a constant. So this can be 2, it can be 3, it can be -4. So if a constant is multiplying x raised to a certain power, added to another constant multiplying a certain power, then you have a polynomials. Polynomials are written in what we call descending powers of x. Okay? So if the highest power is 5, you will get x to the power 5, x to the power 4, x to the power 3, x to the power 2, x to the power 1, x to the power 0. Anything to the power 0 will give you 1, a constant. So we want to now interrogate what polynomials are. Now, so let's learn some few terminologies. When a number and a variable are multiplied, the product of this is called a monomial. So a number and a variable. So if I have, let's say, 2x, 2 multiplied by x, that is mono. Okay, 2 multiplied by x, that is mono. Now, if I have a polynomial with exactly 2 terms, then we are talking about a binomial. If I have a polynomial with 3 terms, then I'm talking about a trinomial. Okay, so the names are determined by the number of terms in the function. Okay, these are terminologies. Now, so let's now look at the few polynomials that we want to. I think I don't go beyond x to the power 3. So let's look at, when we say a function is constant, then we are talking about a polynomial with a constant value. Let's say f of x equal to 3. Now you see that this equation, on the right-hand side, you have a constant 3, okay? This means that this should be 3. I think it's typo. So this means that x is being, 3 is being multiplied by x raised to the power 0. So the degree of a constant function is 0. Please, I hope you follow. The degree of a constant function, when you say y is equal to 2, or y is equal to 3, or y is equal to half, that is a polynomial. The degree of that polynomial is 0, because y doesn't depend on x. The equation we have on the right-hand side doesn't depend on x. So we call it a constant function. Now, when the degree is 1, the input of the variable has a highest degree of 1, then we call it linear equation. So linear functions are simply polynomials with degree 1. So 2x minus 3, you see that the power of x here is 1. It means that the power of x here is 0. So this is linear. 2x minus 3 is linear, or x plus 3 is also linear. Now, quadratic equations is when the degree is 2. So we are determining these names based on the degree of the function. When the degree is 1, then it's linear. When the degree is 0, then we say it's a constant function. When the degree is 2, we say quadratic. When the degree is 3, we say it's a cubic function. Okay? That is how polynomials are defined. Okay, either by their terms or by their degrees. If it's by their terms, we call them mono. bi, tri, and on. But when they are defined by their degrees, then we call them linear, constant, quadratic, cubic, quartic, quintic functions. The names are determined by the properties of the function. Okay, so that is the names given to these functions. Now, there are a few functions we need to look at. There is a function called power function. So power functions are functions that are expressed as monomials. So there is only one term, where the a is a coefficient and n is a degree. The exponents are real numbers. So x raised to the power n. So a times x raised to the power n is a power function. Now we like to play around and graph some of these functions carefully. So now, for example, let's take care of these examples we have here. Y is equal to x squared, y is equal to x raised to the power half, and y is equal to x raised to the power minus square root of half. So let's go and see how they look like. I like to be practical. So let's come here and pick an equation editor. I hope it is open. Okay, so I hope you remember the equation we have. First of all, y is equal to x squared. That's a quadratic equation. So if we want to plot this equation, how will it look like? Okay, so we come here, we say plot y is equal to x raised to the power 2. Sorry, x raised to the power 2. Okay, so this is a quadratic equation. I hope you can see by virtue of what we have. This is a quadratic equation. Okay, and then let's pick the next relationship. Y is equal to x raised to the power half. Y equals to x raised to the power half. So y equals to x raised to the power square root. This is square root, so it means that raised to the power 1 divided by 2. Okay, so that is that function. Start from here. If we minimize, you will see that it will give us, it starts from the positive value of x and goes the way like this. Okay, so y raised to the power square root of half. Okay, then the third example was, sorry, and I think what I did is y raised to the power square root. Now I want to find y raised to the power x raised to the power square root of 2. Square root of 2. So y should be equal to square root of 2. How do we do square root of 2? So that means that x raised to the power and then square root. What is my square root? So that means 2 also raised to the power 1 over 2. Now I have it. I hope you understand square root of 2. There's the way to it. It will give me that green function that we have here. Okay, so these are power functions. Okay, these are power functions, and this is how they behave. Basically, that is the whole idea behind these power functions. They have peculiar properties, and sometimes we need them in analysis of some of the things that we do. So with the help of AI, we can be able to plot and have give an answer to what these functions looks like and how they behave. Okay, so I think my last example should be the rational function. I told you that the questions I'm giving you, they are rational function. So rational function, function. Yes, please.
Sorry. Yes. How are you able to type the raised to the power?
I use the what do you call it? If you are using a keyboard, the symbol on top of 6 is a raised to the power sign. I'm talking about.
Okay.
So if you pick that,
thank you.
It's able to give you that. Okay. Okay. So we want to look at, I think for now, the last example. We've done more than an hour already, so I don't want to go beyond that 1 hour. Even though the period is 2 hours, I mean, let's not do too much that we will have a lot more to go over if we don't understand. So let's manage with this. The materials will be online. If you want to go ahead, fine. But so far as I'm concerned, I want to end on rational. So rational functions are functions that are expressed as here. The word here is ratio. Okay. It's coming from the word ratio, the ratio of the polynomials. So the numerator will be a polynomial, the denominator will be a polynomial. So it is written as h of x and then g of x, such that the g of x, I think there's something wrong. It is h of x. Give me h of x. It will be given as f of x and g of x. There should be something here. F of x and g of x. And then they must be, the g of x must not be equal to 0. So this is a polynomial. The numerator is a function, the numerator is a function. So examples are like this. Okay, examples are like this. Now I'll try and plot one or two of them, but for you to be able to know how to plot these things, there are a few techniques you need to know. We have to know what we call a vertical asymptote, a horizontal asymptote. Do we have an what do you call it? A slant asymptote? Does it have what do you call a hole? It's a whole lecture on its own. Analyzing these functions, there's a whole lot of that goes into it. But for now, we are only interested in being able to know how they look like. So let's try h of x, x divided by x plus 1. Let's try that. So we come back to our AI. So let's get rid of all this. Or I can ask it to do, let me just clean it. So x divided by x, what was the equation? X divided by x plus 1. So the numerator is x, the denominator is x plus 1. Okay, and that you see that when you take your time and you look at it, you see that this line approaches something we call a horizontal line. The horizontal line is when you will we call it the horizontal asymptote has to do with the degree of the numerator and the degree of the denominator. If the degree of the numerator is the same as the degree of the denominator, then you take their coefficients. So the coefficient of this x is 1. The coefficient of this x is also 1. So it's actually y is equal to 1. So if you take your time, this line is cutting the y-axis. It's approaching a y-axis at y is equal to 1. And then this vertical line, you see that when you go down, this line is approaching a vertical line. It's x is equal to 1. How did we do that? Sorry, x is equal to minus 1. You will equate the denominator to 0. Please, I'm going to give you notes on all this, detailed notes. So when you equate the denominator to 0, you see that x is equal to minus 1. So this rational functions, they are functions that approach what we call some imaginary vertical and horizontal lines. These imaginary vertical and horizontal lines, they are known as asymptotes. And the asymptotes are vertical, horizontal, and slant. And to determine them, you will have to analyze the function itself. And that helps us to do this. So I'm just showing you that this graph is approaching a horizontal line as x equal to 1. And this one is approaching a vertical line at x equal to negative 1. And it will go on to infinity. It will never cross it. If you have a good graph, it will draw as far as it can. Okay, so this is how these functions looks like. Maybe let me take the second example so that you can see the difference. This was x divided by, what was the denominator? It was x squared plus x plus 2. X squared plus x plus 2. So we have x raised to the power 2, then plus x, and then plus 2. Okay, this is really, I don't know whether you can see it. It's like a gymnastic. It's also approaching a horizontal line. It's approaching a horizontal line, one on the positive side of x and then one on the negative side of x. But apart from that, you don't have what we call a vertical asymptote. I think when you equate the denominator to 0, you are not getting what we call real roots. Maybe that might be the reason. Okay, so that is how the graph of the second example looks like. The more I expand, the more you realize that the line is approaching a certain vertical line, sorry, a certain horizontal line on the negative side and then on the positive side. Okay, so we can easily interrogate these functions gradually based on the properties that they have. And like I said, every function tells us what it can do or what we use it for. So all that we've done so far is that when you are given a polynomial we can determine one, the degree of the polynomial. We can determine whether it's a constant function. We can determine whether it is monomial, binomial, or trinomial. Is it linear? Is it quadratic? Is it cubic? So on the left, I have the number 5. 5 is a constant value. The degree of 5 is 0. So if I say y is equal to 5, it becomes a constant function. And it's mono because it's made up of one term. The second example, I have 2x minus 4. So you see that the degree here is x is raised to the power 1. So the degree is 1. That means this is linear, and it's known as a binomial because there are two terms. When you come to the quadratic equation here, the degree is 2, and therefore, again, it has two terms, so it's binomial. But when you come to the cubic function, the degree is 3, it's cubic, but it is trinomial because it's made up of x cubed, 4x squared, and then 1. Okay, so that will be where I'll end. The rest are trig. I don't want to go to trig right now. That's also a whole ball game. Okay, so B, electrical and electronics. Any questions, any comments? I'm going to drop in your chat room right now the questions I've just shown you, and please take your time and try them. I'm also going to place it in the, what do you call it, on the LMS as well, so that you can also have time and then download them if you are not able to download it here. But basically, please, this is what I have for you today. I'll continue to work on the LMS so that I can update it with the PowerPoint I've just showed you. Okay, so look at the chat room right now. The two worksheet functions are there right now. Okay, I'll try and add more on the LMS. And hopefully by the end of the week, you will see if there is any assignment that I want you to try. These one, they are practice questions. So kindly practice them and see whether you can identify their functions, their domain, and their properties. Okay, so any questions, any comments, any recommendation? I know you said sometimes I go fast. That one, I've taken it and go fit. Engineer, Philip, what's your question, please?
Sir, please, I want to be sure of this. You said the degrees of a constant function is 1 or?
No, it's 0. Constant function, the degree is 0.
Okay. Thank you, sir.
Welcome. Okay, any other? Okay, if you don't have any more for me, let me just brush through what we did today. So if you didn't join us right from the word go, we basically went through one, steps that you need to be abreast with. We went through the website that information are placed, the website where results are placed. That's the first thing we did. And then we went and looked at the course outline, which is on the LMS. And then we saw how to use Socrative, which some of you have done already. By the way, the Socrative you did, currently these are the people who have logged in, okay? So all the people who have logged in and done it, your details are here. So that is for Socrative. And then we came and looked at how to form groups, okay? So the groups is where the group questions are solved. So when I give you group questions, then you submit a group answer, okay? And I gave you an example of some group questions, the way they look like. So you look at the group question and you choose your group and then you answer. So that was for the steps. Then we came and looked at the course outline. I showed you all that you need to know about the course outline. And now the grading system are taken care of. And basically, the topics that we'll be dealing with unit by unit. So today we have been able to look at from session 1 and look at session 2. Okay, God willing, maybe next week we'll look at the last 3 sessions as well. Okay. And then I also told you that on the LMS platform, there is a book that has all the details of what we've done. So you can use the book. We call it a model test book. And also, there are some few questions. The questions are not many. Okay, so you can try that as well. Then the last thing was I went through some few PowerPoints, and I'm saying that hopefully by the end of today, I will upload the PowerPoints here. It will be underneath this step because we just did this to be here. And then all the other information with respect to the unit 1. See the unit 1, start from here. So the PowerPoint should cover up to here. So the ones we've done, the ones we haven't done, they will all be there. Okay, so basically that is what I have for you. If you're okay and you don't have any more questions for me, then God willing, next week we'll continue from where we left off. And please don't hesitate to contact me via my social media page. I'm talking about WhatsApp, or maybe send me an email if you need something before the weekend. Okay. So thank you for coming. God bless you, and have the rest of the day as well. God bless you. Bye.
Thank you very much, sir.
You're welcome.
God bless you too. Hello, guys. So, good afternoon once again.
Good afternoon.
Good afternoon, sir.
We have to wait for how they call it, communication skills.
Okay.
I think with that one we can stress more as we wait for her. So with that one, the time is 3:15 to 5 p.m. 3:15. So at least we have some 45 minutes. So let's break up, stretch ourselves in waiting for her. So whatever be the case, we communicate in the WhatsApp page.
Okay.
All right.
Okay.